Hey everyone, today we're going to talk about the need for addressing. And to get started, I want you to imagine that you're in a room with 5 people and you all have the same name. What would happen if you attempted to start communicating? All right, so to kind of walk through this, during our last class, you created a network that had strengths and weaknesses. Today we're going to use a tool where one of the strengths is that everyone is connected and can get communications quickly at the same time. And from our discussion, you might be starting to understand some of the weaknesses of this type of network. There's an activity guide on the Google Classroom that looks something like this. And with your group, you're going to be in a group of 5 or 6, and with your group, you're going to follow the directions given in the box for week 1. So take a moment, get the activity guide out. If you are remote, you can hit pause, all right? And with your group, follow the directions given in box 1 for week 1. If you're a group of 5, everyone cross out Sunday. If you're a group of 4, everyone cross out Sunday and Saturday. Before starting to schedule each week, choose a random day of the week when you're busy and cross it out. Okay, then you're going to fill in your schedules. With your group, check that everyone's schedules match. Then discuss what worked well, what made this tricky, if there's anything you want to try differently. Week 2. If you are a group of 5, everyone cross out Sunday. If you are a group of 4, everyone cross out Sunday and Saturday, and then cross out a new random day. And then we're going to transfer this over into the Internet Simulator. And in the Internet Simulator, I'm going to give you about 10 minutes. You're going to set up your boards for week 2 in the same way as you did the last time. With all the same considerations, you're going to join a room with the same people that you had kind of done the unplugged version with. And once everyone is in the room, you're going to complete week 2, but on the simulator with absolutely no talking. And with the attempt to be that you're communicating this way, okay? I'll give everyone a moment to open up the simulator. Okay, and you're going to fill out the table on the back side of your sheet, and with the idea of what problems did you have when communicating on the Internet Simulator this time around? What solutions did you create or would you like to try for week 3? And we'll discuss that. And then for week 3, another about 10 minutes, you're going to agree with your group on a set of rules. Okay. Agree with your group on a set of rules you'd like to try this time around for how to communicate. Then complete week 3 like the previous 2 weeks. No talking. Okay. And based on your experience, take 5 minutes to write down in the rules section the collective rules, which for the internet we call protocols, that you and your team would advise using going forward. Okay, and then you complete week 3, but no talking, and explain your rules and how this worked for you.
Hi, my name is Paula, and I am a software engineer at Microsoft. Let's talk about how the internet works. My job relies on networks being able to talk with one another. But back in the 1970s, there was no standard method for this. It took the work of Vint Cerf and Bob Kahn to invent the Internet Working Protocol to make communication possible. This invention laid the groundwork for what we now call the Internet.
The Internet is a network of networks. It links billions of devices together all around the globe. So maybe you're connected with a laptop or a phone through Wi-Fi, but then that Wi-Fi connection connects to an Internet service provider or ISP, and that ISP connects you to billions and billions of devices around the world through hundreds of thousands of networks that are all interconnected. One thing that most people do not appreciate is that the Internet is really a design philosophy and an architecture expressed in a set of protocols. A protocol is a well-known set of rules and standards that, if all parties agree to use it, will allow them to communicate without trouble. How the Internet actually physically works is less important than the fact that this design philosophy has allowed the Internet to adapt and absorb new communication technologies. This is because in order for a new technology to use the Internet in some fashion, it just needs to know which protocols to work with. All the different devices on the Internet have unique addresses. An address on the Internet is just a number, similar to a phone number or a sort of street address that's unique to each computer or device at the edge of the network. This is similar to how most homes and businesses have a mailing address. You don't need to know a person to send them a letter in the mail, but you do need to know their address and how to write the address properly so the letter can be carried by the mail system to its destination. The addressing system for computers on the Internet is similar, and it forms part of one of the most important protocols used in Internet communication, simply called the Internet Protocol, or IP. A computer's address, then, is called its IP address. Visiting a website is really just your computer asking another computer for information. Your computer sends a message to the other computer's IP address, and it also sends along its origin address so the other computer knows where to send its response.
You may have seen an IP address. It's just a bunch of numbers. These numbers are organized in a hierarchy. Just like a home address has a country, numbers are organized in a hierarchy. Just like a home address has a country, a city, a street, and a house number, an IP address has many parts. Just like all digital data, each of these numbers is represented in bits. Traditional IP addresses are 32 bits long, with 8 bits for each part of the address. The earlier numbers usually identify the country and regional network of the device. Then come the subnetworks, and then finally the address of the specific.
Okay, it keeps cutting off. I'm not sure why, but I will attach the video, the direct link to the video. I've tried to re-record it several times, but I'll put the link to the YouTube video on the Google site as well. Okay? All right. Let's continue along. And then I just want you to think, as we wrap this up, what are the similarities and differences between the Internet Protocol and the addressing rules our class made? Would rules like our or the IP work if they were secret? Right? So if you didn't share the rules, and again, I'm going to say, this is how the protocols of the Internet came together. People kind of getting in a room and wrestling with all of the logistics of how to best communicate in a clear way with shared rules, or protocols, as we say. So here, a protocol is an agreed upon set of rules that specify a behavior of a system. An IP address is the unique number assigned to each device on the Internet. That's any device that is attached to the Internet or interacts on the Internet, sends information on the Internet. So your phone, your computer, depending if your Apple Watch is directly connected to the Internet or not, your watch. And then the Internet Protocol is a protocol for sending data across the Internet that assigns unique numbers, IP addresses, to each connected device, right? That's your address, the same way you would have an address when you're sending regular mail. Okay, we'll end there.